are the classifiers or regressors? See, there are 5. You can see and tell me what are regressors and what are classifiers. Yes, the first one, is it a regressor? Yes. What about second one? It is a classifier. Third one? Current status. Okay. So it is a third one is a regressor. Okay. Ticket is confirmed, not confirmed is classifier. We are knowing whether it is a waiting list or not, what is the number you are assigning. That is a regressor problem. What is coming to fourth one? Fourth one is a classifier and fifth one? Cluster. Classifier, sometimes we can go with clustering also based on the features. Okay. Yes. So this is one important question that we are expecting in. So which is not a classifier, which is not a regressor, like this. Okay. Coming to the data set, already we have worked on the data set, and what are the things that we have done? What are the things that we have done? First one, we have defined the random state. Second one, we have done training and splitting. Third one, what we have done? We define the model. Then we have fitting the model. Next, what we have done? We have predicted. So what are the things that we have done? We have declared the random state, and we have splitted the data, and the third thing, we model the data. Modeling can be done based on the algorithm. If you choose linear regression, if you choose logistic regression, if you choose some other any algorithm, it can predict something. Okay. Next, we are fitting. And fifth one is the thing that we need to do after the prediction. Next, after predicting the values, we have one more step. Yes, just now in mathematics, sir talked about a random variable. So when we are talking about a random variable, we are doing an experiment randomly so that we are expecting the outcome. To do, we are doing an experiment randomly such that we are expecting some outcome. Okay. Now, when I have a data like this of 10, what I am trying to do? What I am trying to do when I have a 10 data which is having a 10 instances. Rows are called as instances, and columns are called as attributes or features, and the last column we call it as outcome or actual outcome. Okay. Now what we are trying to do, whenever I do an experiment on the data set, the random state is 1. When we do an experiment on 2, when I do second experiment, the random state will become 2. So on, whenever we are doing some random experiments on the data, always it picks the data randomly and do the experiment so that it gives an accuracy. When I have done 32 experiments, I got some accuracy of 70%. When I select random state of 65, I got 80%. If I choose 25 experiments, I may be 95. So, when I am preferring a random state, I am doing the experiment for that many times so that average of our accuracies, I will take it as some 80%. So, it depends on the random state and how many experiments are doing on your data set. Okay. Now, which random state I should prefer? Which random state I should prefer? Always I should prefer a 25. I need to prefer a random state which is at 25. When I prefer the random state, what I have done, I can do one more thing which is our training and splitting. What is training and splitting? Out of 10, if I split the data set of test size of 0.2, how much out of 10, how many are training data set and how many are test data set? So, 8 are our training data set. Yes, please. 8 are our training data set and 2 are our test data set. This is our X train, this is our X test and this is our Y train and this is our Y test. So, what I have done, I have splitted the data as X train and Y train, Y test and X test such that I'll train my model with a trained data. I'll train the model such that I'll give all the training. Once the model is done, what you are getting? We are getting the accuracy. Are you getting directly accuracy? Yes. Are we getting directly the accuracy? No. We won't get accuracy directly, but we need to calculate the accuracy. That method is called as evaluating. Yes. If the error is more, if when we talk about an accuracy, always the error is more. If error is more, what we need to do? We need to optimize. What we need to do? Most of the data scientists are paid for this too. One is for optimization and one is for evaluation. Model fitting anybody can do. Optimization normally a person cannot do. What is optimization? How we are doing optimization? What is the need of optimization? We are going to see today. Okay, yes? So, we understood that always we are trailing on a method such that we are expecting some outcome or expecting some accuracy out of it. Okay. Next. Models can be many. Okay. See that. How many models we have? We have a regression. Always we go for a regression which is linear regression. And second one is we have a problem which is a classification problem. Which is a classification problem. See how many are there? Logistic regression. Always when we go for logistic regression, when we have Boolean valued, yes or no, When two are there or multi-classes are there, we go for logistic regression. When we go for discrete decision trees, when we have discrete valued. When the outcomes are discrete, means it can be a real number, it can be a Boolean valued number. Okay. So, coming to the random forest. Coming to the random forest, it is the extension of your decision trees. Next is K nearest neighbor, KNN. Third, next is Navy Bayes. Always it works on a principle of Bayes theorem. Next, third is support vector missions and artificial neural networks. In tomorrow's class, last three topics maybe sir will cover. But I cover up to KNN, which are very, very important for your exam. Okay. Logistic, normally we go for Boolean value. Okay. Classification. How many types of regressions are there? There are three types of regressions. One is called as linear regression. One is called as multiple regression. One is called as polynomial regression. Now, we are not going to see what is regression, but we are comparing the linear regression with logistic, or we compare logistic with linear regression. When we do multiple things, multiplications, normally we need to have a logistic regression as a single layer. Okay. Next, we use one odds. Already, whenever we talk about odds, always we talk about probability. Next, we call sigmoid. Next, we call it cost function. Next, we will do 5 problems. Please remember that. Already you know the problems, but I'll give an overview on that problems. Okay. Next, coming to the types of logistic regression, there is a binary logistic regression, which is when we have two variables, which is called pass and fail, yes or no. Normally we go for binary classification. Multi-class classification, when multi-variables are, multiple outcomes are there, we go for that. When we have ranges, normally we go for ordinal features. Okay. Next, coming to the logistic regression. See there, I am not mostly concentrated about the definition. See, what is a logistic regression? Logistic regression is a statistical method for analyzing the data set in which there are one or more independent variables to determine the outcome. So, we have an age. A person is handsome or not. If you want to define an outcome, always we refer with a age. Age means always we go with dependent or independent variables. Coming to the outcome is measured with two possible outcomes. Normally we go with logistic regression. Coming to the here, I am not interested in this model. What is this model? Logistic regression, giving some inputs, getting some outputs, happy or sad. This is not my idea of an engineer. But I see the inputs and the weights and the outputs. See there, what is that? Inputs, weights and the outputs. What are inputs? Whatever the features that we are giving as a column, they are the inputs. Whatever we are talking about randomly selected, which are called as weights, and the outcomes that we are expecting is happy or sad. Okay. Next, coming to the when I want to compare my logistic regression with the linear regression, always we say there is a fit of line. So we saw a model. What it has done? It has divided into yes or no, which is nothing but I am calling it as classifier. Next is, my idea is about fitting. This plays a very important role in our ML. Okay, fitting is very important in our ML. Okay, always remember that here we are fitting the line towards the x and y variables, which is 2D form, which is about 2D form. When I draw the I'll take only one variable and one outcome. Here we have a x variable. I am taking only one column. And how many outcomes are there? Based on that, again we have split it. How we have split it? We have split it into 80% and 20%. How many are there in the training data now? 8 are there. So, what I do, I use a scatter plot and I model all the 8 samples here. I model all the 8. So, what I have done, yes, what I have done, whatever the 8 instances are there, how many data points we have now? Each is called a data point. Each is called data point. If 400 instances, yesterday we saw the data set is having 400 instances, so that 400 rows are there. Means how many dots will be there? 400 dots. Now on that 400 dots, what I have done? I have fitted the line. I have fitted the line. When I fit the line, these are the actual values. Sorry, these are the predicted values. These are all the predicted values such that we are calculating these are the predicted ones, these are the actual ones. In between this predicted, in between the predicted and the actual, there is something which is called what? Can anybody tell? Can anybody tell? Normally we call residual or we call it error. How many errors are there now? How many errors are there? How many errors are there? Totally 8 errors are there. Okay. When I want to plot this line, how I have to do? Y is equal to x1 plus x2 plus x3 plus x4 plus x5 plus x6 plus x7. When we do some assumptions, there will be a x0 or we take it some x0 to x7. This x0 we call it bias or assumptions. We call it as assumptions. When we do assumptions, there is a one called as coefficient and also intercept. So always each variable have some coefficient. See there, what is there? Y cap is equal to, what is there? Y cap is equal to beta naught plus beta 1 x. Yes. Is there any slope change here? Is there any slope change of this line? Is there any slope change of this line? No. Means the beta 1 is constant. When we take the slope of the line, beta 1 is constant. Where is it started from 0? No. It is starting at 15. That's why the intercept starts at 15. Okay. Now, what are x? X are all x1 plus x2 plus so on x8. So, this is not small x, but it is x which is having all the data point such that we have all the features. When we talk about, now I have taken one x1 and y, so that I am having x1 to xp. What is xp? xp is number of features. Okay, you understood? Yes. Next, coming to the, anybody have doubt in this? You understood? x1, xp, x1 to xp are multiple features. X is single feature. Okay. Yes. Now, when we talk about error in regression, how we have to calculate error on regression? Error on regression. What are the formulas we have? Okay. One more important point I need to cover here. When we have y cap is equal to beta naught plus beta 1 of x. X is a feature. Now, it is in which dimensions? Single dimension, and x is also a single feature. When we talk about multiple features, whatever the combination of attribute is there, it is the combination of x1 and it is the combination of x2. Means you are fitting the line where we are fitting the line. Are we fitting the line in 2D for multiple features? Let me take, this is about x1, this is about x2. Yes, please. I have a x1 feature, I have a x2 feature. Where I am fitting the line? I am fitting the line which is with the y-axis x1 and also y-axis. Means somewhere in the surface, always we are fitting the line. When fit the line, are we knowing the slope? Do we know the slope? No. It depends on x1 feature and depends on x2 feature, and it is lying at an angle. It is lying at an angle. That's why my prediction, I'll change it as theta 1 plus theta 2 of x. Why I am changing theta 1 plus theta 2? Why? When I take multiple features, always the angle will include into my features. When I include my features, I cannot call this as a prediction, but I call it as h of theta. Hypothesis of theta. Hypothesis is nothing but it is the fitting line. Hypothesis on the theta is equal to theta 1 plus theta 2 into x. Okay. Now coming for the RMSE. You know RMSE calculation? Yes? Now when we are having multiple features, how can I write this? How can I write this? Can I write like this? Y cap is equal to summation of I1 to n, which is nothing but Wi or theta I into xi. Can I write like this? Yes? Can I write like this? Can I write like this? Yes? Now, what is there? When I talk about y cap is the summation of your I1 to n to theta I into xi. Can I write this like this? Yes? Can I write like this? In the theta I place, can I write W transpose? Yes? I'll try to write W transpose X. When I talk about an image, always I talk about W transpose X. When I talk about numbers or data, I talk about theta I plus xi. Okay? Yes. Next, when we are doing regression, we are not directly, what is xi, yi here? What is yi? Yi. What is yi? Actual outcome. What is y cap? Predicted out. Actual minus predicted gives error. Overall, all n. Predicted minus actual gives your error. Whenever we take the absolute, means you are converting magnitude of the error. This is called mean absolute error. Or we call it as root mean square error. In regression, are we directly calculating the error? In regression, are we calculating error directly? Yes, through RMSE, MSE. Can we calculate accuracy? Can we calculate accuracy in regression? No. If you say error is low, automatically we say accuracy is high. In regression, we cannot directly evaluate accuracy. Through an error, we calculate accuracy. Okay. Next. What is this? Yes. I want to convert my linear regression to logistic regression. Yes. Regression is used for number. Always logistic is used for Boolean values. Can I use the same fit to classification problems? Can I use the same fit and keep on changing the threshold of your line? I have, what is the tumor size? Tumor exists or not? If I want to predict, can I take this fit? No. Always we need to do something such that you need to convert this straight line fit to another form. Okay. So, can we go for thresholding? Change the line towards this. Change the line towards 0.8 and say tumor is detected. Change the line to 0.5, 0.2 and say detected, not detected. No. always we need to go for logistic regression. Natural logarithm of regression is our logistic regression. Natural logarithm of our regression is the logistic regression. Next, we need to get regression. What is the regression? Regression? What is the regression? Y is equal to beta naught plus beta 1 x is your straight line equation, which is converted into a logistic regression. Where can we convert directly? No. Always we need to take the probabilities of your regression. When we take the probabilities of your regression, we take the probabilities, always the probability is greater than 1 or less than 1, less than 0. So to avoid that, what we need to do? We need to take the odds of P. When we take odds of P probability with a log function on a linear function, what is the result? See, I have applied logarithm over the odds and on the straight line equation such that what I got? The resultant is what? What is the resultant? It is the, what is that? When I go for all the logarithm on this, I got the result as sigmoid function. If you got the sigmoid function, always the probabilities of the outcomes are between 1 and 0. What are the probabilities? Always the probabilities are on the feature is resulting between 0 to 1. Yes? So, what I have done? The same linear regression, the linear regression is converted into, your, what is this? What is this? Sigmoid function. Sigmoid function. How it looks like? How it looks like? 1 divided by 1 plus e power minus y. 1 by 1 plus e power y. This is called as activation function. What is this called? This is called as activation function. Always in convolution neural networks or KNN, normally we use what? Activation function. Always we try to predict the output between the 1 and 0. In the same fate, we are converting into a logistic regression. Okay. Now, can we call this prediction as hypothesis search? Can we call this as the straight line equation as hypothesis search? Yes. Y cap is equal to beta naught plus beta 1 x. It is in place of y cap, I have placed h theta of x. In place of b naught, I have taken the theta naught. If in place of beta 1, I have taken theta 1 and x is the features. X is our input and y is our predicted output, and theta 1 and theta 2 are the coefficients, or we call it simply the weights. Simply the weights. Can a hypothesis create a best fit? Yes. We have taken some straight line equation or some equation such that this hypothesis can create a best fit. When you fit the line, always it improves the accuracy. It improves the accuracy. When we fit the line, please recall the line is lying in 3D surface or n-dimensional surface. We have 10 features. In 10 features, the dimensionality is 10 such that our fitting line is lying in between 10 dimensionality. That's why we try to go with. Yes, when I fit the line, when we fit the line, there are 3 possibilities. What are the possibilities? There is a underfit, there is a optimal fit, there is a overfit. When we have underfit, always we have high training error and high testing error. When we have high training error and high testing error, normally the fitted line will have underfit. When we have low training error and high testing error, always we go for, it affects with overfit and it has high variance. In which type of fitting model will get overfit? When we get overfit, when we get overfit, when we have high variance. So yesterday when we talk about binomial distribution, when we talk about normal distribution, mean, variance and standard deviation. When we have lot of variance, always there affects with a overfit. When we have high bias, when we assume many, always it goes with underfit. This fitting is called as underfit. Why? Because it is not classifying well. When we go for this, we have fitted the line in polynomial such that it has classified well. When we have overfit, always we have overfit which are classifying all. Means, can we have 100% of accuracy? Can we have 100% of accuracy? No. Why? Why? Because it affects with overfit. When we get overfit, as we take multiple features, means as the model complexity increases, error also increases, but what is happening? Training error is reducing and we say that there is underfit, overfit and there is a best fit line. Coming to the logistic regression. Have you heard about any word called cost function? Have you heard about cost function? These are all the bits we'll get. Whenever we get, when we get overfit, when it has high variance, when we get underfit, when we have high bias. When we have high bias, variance is low. When variance is high, bias is low. Please remember that for a good model, we maintain a low variance and low bias. Okay. Coming to the logistic regression. Logistic regression, we are talking about cost function. What is cost function? Why we need to write j theta? I want why we write j theta, why we write 1 by 2 power m. Are we doing classification? Are we doing discrete values? Yes, we are doing discrete values. So we are doing on a theta slope, which is on a theta slope such that it is varying the magnitude of the angle. When we talk about j is always we try to take in complex number. So what is cost function? Cost function is j theta is equal to 1 by m summation of I is equal to 1 to m. In brackets, what we need to write? What we need to write? H of theta of x is what? It is the hypothesis. Hypothesis is used to best fit. The best fit is resulting the predicted output. Minus the actual output. The cost function is also called as error function in our logistic regression. Yes, what is cost function? Cost function is equal to 1 by m summation of I is equal to 1 to m of cost of h of x comma y. Y is our actual value and h theta of x is our predicted value. So actual minus predicted gives your error, and we are indirectly averaging them. Sometimes we take 2, sometimes we take only m. When to take m, when to take 2m? When you are converting totally between 0 to 1, or when we are taking from minus 1 to 1. So what we try to do? The cost function or what is the error in regression? What is the error in regression? Yes. What is the error in regression? MAE, MSE, RMSE. If errors are high, we say accuracy is low. Is there any separate procedure for calculating accuracy? No. Directly, if you see error, you need to calculate accuracy. Coming for the logistic regression, using a cost function, we can calculate the error. If error on the cost function is high, we say accuracy is low. This is one way to do. But we have one more procedure called as evaluation. What we have done, we have calculated error yesterday when we are talking about logistic regression. We have calculated errors between predicted and actual, and I have printed one more. What is that? Misclassifications. What I have printed? Misclassifications. If you do 1 minus misclassifications, you are going to get classifications. Means you have classifications, true positives, and we call it as true negatives, false positives, and false negatives. From this we can evaluate. Okay. Next, we evaluate if more classifications are there. We say accuracy is very, very less. But how to optimize is the question. How to optimize? Is there any procedure? we know features are fixed. We know output is fixed. What we can change? In this, yes, y cap is equal to beta naught plus beta 1 x. If x is constant, x is fixed and y is also fixed, what we can change? We can change the coefficients. We can change the coefficient. This changing of coefficients is called as gradient descent. What is that? We are changing the coefficients to reduce the weight, which is called as gradient descent. When we talk about gradient descent, always we need to know about convergence. Always we have multiple features, there we have multiple minimas. When we have multiple minimas, always we need to converge into a global minima. Okay, yes. Yes, these are all applicable for your, what is this? See there, j of theta naught, theta 1, what are they? What are theta naught and theta 1? They are the coefficients. On that I am doing j. Why? What is j? Cost function, which is equal to 1 by 2 power m summation of predicted minus actual value whole square, such that I am doing gradient descent. How I am doing the gradient descent? When I say the model, please see here. When I visualize the model, this is called as, sometimes we call it as histograms or we call it as the counter graph. When we model this graph, always based on the error, somewhere there is an error here. When we want to change the error, what are the parameters that I am changing? I am updating the theta naught and theta 1 such that I am going to get into a saddle point. When I get into a saddle point, this is the flag that we have, that is the best fit. When to, up to which point we need to update the weights or update the theta coefficients, until which we reach the saddle point. What is the saddle point? How to do that? See here, the new theta value is equal to old theta value minus learning rate into your error. Error into learning rate minus old theta value is equal to new theta value, such that you get a new weight. If the error is more, what we do? Update the weight, update the coefficient. So until which point we need to update the weight? Until it converges to saddle point. What is saddle point? Where the accuracy is more. Global minima. Normally no person can get in any model, we nowhere get the global minima. It is very hard to get the global minima. Always we lay at local minimas. So which is having best features, where that featured local minima it goes. Okay. So when I want to talk about this, I thought of showing how we update the weight. What is here? H theta of x? What is H theta of x? Is a logistic regression supervised? Yes, we are using labeled data. Can you tell me one example for unsupervised? K means clustering. Yes. Can you see this? Yes. See there. My global minima is somewhere. I am trying to get my local minima by using different optimizers here to reach into a saddle point. So how many types? We have different types of optimizers. Please remember that. Okay. We have discussed about the logistic regression, where we are using at the last layer of our artificial neural network. So whatever we have, see here. This is the single layer perceptron, where we have summation of all the values of all the inputs, which are nothing but, there we are talking about theta naught and beta naught. In artificial neural networks, normally they are called weights. Weight into x1, weight into x2, weight into x3, all summation of all the weights into input features are given to a one activation function, which can be our sigmoid function. What is sigmoid? What is the equation of sigmoid? 1 by 1 plus e power minus y. 1 by 1 plus e power minus y, such that it always detects the output between 0 to 1. 0 means not classified, 1 means classified. Coming to the problems. Now we have discussed about linear regression, we have discussed about logistic regression. There we have one problem. Try to do with me. Just now we have discussed this cost function, right? I have a table which is having x and y. X are the features and y is the outcome. I have a hypothesis that I am using, where I need to predict the new variable which is having theta values as 2, 1. Substitute the value 2, 1 in theta 1, change the values of x such that you are going to get the summation of all the values, you get it as cost function value. Write down the formula for cost function. What is the cost function? What is the table? And what is the hypothesis? These three are very, very important. And the new instance that we are getting is theta is equal to 2, 1. I have theta naught as 2 and theta 1 as 1. Change the weights and find out the new error. We are finding the new error based on the weight updates or theta updates. Consider a linear regression with a hypothesis as theta or h theta of x is equal to theta naught plus theta 1x. The training data is given in the table. You have different x's and you have different outcomes, and you need to find out the error. Why? Because we have how many instances? 4 instances. What is the predicted value for the first instance?
8.
What is the predicted value of first instance? 8. And the actual value is 7. 8 minus 1, there is an error. Coming for the second instance, what is the predicted value? 7, but what is the actual value? 4. Coming for third instance, what is predicted value? 12 and the original value is 9. This is how we need to find the error on every instance and sum it all that and take average. Yes? Coming for this. In a binary classification, out of 64 data points, 29 belongs to class 1 and 35 belongs to class 2. What is the entropy of the data set? Minus summation of pi log base 2 of pi. Pi log base 2 of pi. How many are able to do entropy? Please raise your hands. Yes. How many classes are there? We have 2 classes. So we write it as P1 log base 2 of P1 minus P2 log base 2 of P2, and we need to take all the minus. Okay. You need to take the minus over. Yes. How many, what is this P1? It is the proportion of number of samples of the first class divided by total samples. What are the proportion? Tell me. What is the proportion of P1? 29 by 64 log base 2 of 29 by 64 minus, what is the second? 35 by 64 log base 2 of 35 by 64. So what are the values? 0.99. It is 0.51 minus 0.43. It's around 9009. Normally we say entropy of S is how much? 0.99. Okay. How much you got? 0.99. See, I am talking about decision trees. Decision tree is a supervised learning algorithm which is used for, please listen, supervised learning algorithm where it can classify or regress. What we have done in the data set, we have done EDA. We have done EDA and we have processed the data. Now I have the best columns in my data set. So I have processed in my data, all features are suitable for my prediction. When I have suitable for prediction, which attribute should I select as a root? Is my question. How I can select as a root for my decision tree? Based on the information gain. Whichever gives the highest information gain, we go with the root attribute. Based on the root attribute, we go for subroots. Based on the subroots, we go for the leaves, which are classifications. Yes? So, how many are there? There is a color, there is a wig, there is a number of years. Based on this, I need to predict the emotion. Based on this, we need to predict the emotion. How many instances are there? Totally 9 instances. How many input features? 3 input features. How many outputs? 1 output. Can I give a last instance which is a new instance g, n and 1? It will predict. Some new instance I give, it will predict. If the model accuracy is best, we can give the new instance. Then it also predicts the output. Yes? Yes. Can you calculate this for me? There we need to calculate entropy of your color, entropy of our wig, entropy of your ears, or the total entropy. Based on that, we need to calculate the information gain for each attribute. How we are calculating? Entropy of S. What is entropy of S? How many outcomes are there in my emotion? How many are there? How many sad? How many sad? Please, 4 sad. How many are happy? 5. 5 are happy and 4 are sad. Can I calculate entropy of the data set? Yes, please calculate. In scikit-learn, just change the name of the model, it gives the accuracy. Change logistic to linear regression, change linear regression to decision tree, it always gives the accuracy. But we need to know what is running behind, which is entropy and information gain. Based on this, we are going to classify the total data. Yes. What is the value of our entropy, total entropy? 0.99. Use of each attribute, and what are the attribute, what are the classes in our color? Green, blue and red. Okay. So, I need to calculate for the entropy of green, I need to calculate the entropy of our blue, and I need to calculate the entropy of your red. Green, once you see green, what are there? How many are positive, how many are sad and how many are happy? All are sad. How many are sad? There are 3, 0. I have 3, 0. So the entropy is equal to 0. Yes. Now, how many are blue? I have a blue. And how many are? One is sad and one is happy. So, I take it as one is sad and one is happy. So, entropy is equal to 1. Next, for red, all are happy. Means 0, yes. Now I need to calculate the information gain. calculate the information gain? 0.99 total entropy minus what are SVs? Total number of reds or green, total number of greens available divided by all. So how much is that? 3 by 9 into 0 minus, how many are there? 2 by 9 divided by 1 into 1 minus 4 by 9 into 0. What is the information gain? What is the information gain? It is 0.767. Similarly, this is for color. Similarly, do for weight, and similarly do for your number of years. Among that, whoever get the highest information gain, that will become the root node. That will become the root node. After getting the root node, what we need to do? We need to do on the samples of your root node. We need to do on green, blue and red. Which is the color? We get color as the highest information gain. This we got 0.046 and this we got it as 0.051. Whichever gives the highest entropy, that will become the root node. Yes, any doubts?
So, how the sessions are going on? So, are you able to follow? So, we have the 10 attributes and 10 parameters. 10 parameters. We have to go with the 10 parameters. Meaning that if you have x1, x2, x3 up to x10, you should have the parameters also coefficients. We can call them as the coefficients W1, W2, W3 up to W10. So, and if you have 100 records, what is the shape of the table? 100 records and 10 columns. 10 columns are there, and how many parameters required? 10 parameters required. How can we represent those 10 parameters? x1, x2, x3, it is like a vector. So, W1, W2, W3, or you can take it as the beta 1, beta 2, beta 3. Beta 1, beta 2, beta 3 or W1, W2, W3. Beta or W. We can use any one of them. Okay, the difference also I will let you know. The notation, where we will use these notations. So, these parameters, 10 columns are there and 10 weights or 10 coefficients are also available. Now, we have the 100 by 10 table, and 10 by 1. Can we say that 10 by 1? If it is a simple vector, 1 by 10, right? It is like a row. If you have the 100 by 10 and 10 by 1, in such case, if you have the multiplication, vector multiplication on this, if you perform the vector multiplication, then we will get 100 by 1, meaning that for every record we will get one output. That is y. That is what our prediction. This is our prediction. 100 by 1 we will get. Right? So, in this case, if you get like this, these 100, what is our intention? Do you want to find the y only? You want to find y? Y equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus up to beta 10 x10. Okay, what is our intention? Do you need to find y? What is our intention? Weights. We have to estimate the weights. How can we estimate the weights? We know y. We know x1, x2, x3 up to x10. Meaning that in the equation, we know one value on this side of equal and other side of equal, that is y. Y equal to beta 0 plus beta 1 and so on. Now in this case, I want to find the beta 0, beta 1, beta 2. What can we do? You have to take other side. You have to take the values onto other side. So how can we do that? That can be represented, actually this data can be represented 100 by 10 can be represented as the matrix and the vector, matrix vector. So if you want to find the beta 0, beta 1, beta 2, beta 3, the slopes or the weights, if you want to find the weights, we have to apply the matrix inverse method. By using the matrix inverse method, we can find the beta 0, beta 1, beta 2, beta 3 and so on, all these weights. There we will apply the matrix operations. I hope you get the point. The total representation of the data, based on the representation of the data, you can apply the mathematics, that is the matrix concept, to estimate the beta 0, beta 1 and so on. I think you get some point between the gap between the mathematics and the machine learning algorithms. Yes, again there is the derivation part, we have to discuss about that. I will show you, wait. Okay, I will give you that. So to estimate, yes, to estimate the parameters there are several ways. One is the statistical formula, by using statistical formula. Another one is least squares method. Another one is inverse, matrix inverse method. Another one is gradient descent method, gradient descent. Another one is by using directly the predefined models, that is by using sklearn, TensorFlow and all. So these are the various methods. In these, one of the method is the matrix inverse. So right? Now, next thing, in the similar way, from the linear regression only we are getting the logistic regression by using the derivative, applying the log on the both sides, and after performing some derivation part we are getting 1 by 1 plus e power minus x minus z equal to beta 0 plus beta 1 x1 and so on. So we are getting this. Again in this also we have to estimate the beta 0, beta 1, beta 2. Again how can we verify that? How can we get the values of beta 0, beta 1 and so on? Estimation. Again we have to estimate the parameters. How to estimate these parameters? So for this, actually for the linear regression we can easily go with the any other method, but from the logistic regression onwards it is better to go with the gradient descent concept. In the gradient descent what will we do is, in the other methods we will have the direct formulas to estimate the parameters. Beta 1 equal to, beta 2 equal to, there are the fixed formulas. But in the gradient descent method what we will do is, we will take the random weights, random values for beta 1, beta 2, beta 3, beta 4. We will take the random values and apply and estimate calculate the output variable. What is the formula? Y equal to, I am taking the linear regression only. In the linear regression only, y equal to beta 0 plus beta 1 x1 plus beta 2 x2. In this we will take the random values for beta 1, beta 2, beta 3 and so on, and let us apply the method. Let us apply the method equation. So you will get y values. How many y values you will get? Already we have the values of beta 0, beta 1, beta 2 and all. We will get some y values, and these y values, the predicted values, they are not equal to the original y values definitely. Why? These are random values. We are calculating based on the random values. So these random values, these beta 1, beta 2, beta 3, these values have to be adjusted. These values have to be adjusted according to the output. Meaning that in the first round, we will apply with the random weights and calculate the y values. Now there will be the difference between these two. How can we calculate this difference? That is the matrix that comes with the matrix. That is mean absolute error, mean squared error, and root mean squared error. Okay, what we are doing right now? There are several phases in the machine learning algorithms. First phase is training. So in this, the estimation in this first training phase, in the training phase, we have to estimate the parameters properly. As a part of that, we are taking the random values. In the next phase, we will go with the evaluation method. Evaluation, meaning that whether our model is working fine or not. In the next level, we will go for the predictions for the new data. These are the three steps for the machine learning. First, in the first step of the machine learning, in the training phase, it should be more strict. In the training method, it should be more strict, meaning that if the error is small, even the error is small, it has to show big. Even the error is small, it has to show big. Why? Because it is training. We have to make the training and we have to make the algorithm more sensitive. Getting? Now, what we have done, we have taken the random values and continue the process. So we get the values of y, predicted values, the difference between the y and y hat. The predicted values are representing with y hat, y predict. So by using the mean squared error, what is the mean squared error? Okay, mean absolute error. First come to the mean absolute error. Mean absolute error means y minus y hat, mod. We have to apply the mod, meaning that error means either positive or negative, error is error only. The track is like this. Okay, for this track, the train is going to this side or that side, either positive or negative, the error is error. There will be the derailment, that is accident, right? So in the same way, the error may be this side or that side, it is equal. So we have to make it as positive. Even the error is negative, we have to make it as positive, and we are taking the average of all the errors. That is giving the mean absolute error. That is for evaluation, it is okay. But for the training means we are setting the parameters of beta 1, beta 2, beta 3. To setting the parameters, we have to set that and make it more sensitive. If the error is 1, if you make it square, 1 square, what is that? 1. If the error is 2, square it. Error is 3, 9. 4. Meaning that if the change of error is even, there is small change in the error, the result is showing very high. Meaning that, so it is more sensitive. So for the training we will take the mean squared error. By taking the mean squared error, based on that value, according to that error value, that is called the loss, we will call it as the loss also. Based on that loss, we have to update the weights, that is the beta 1, beta 2, beta 3. Okay, based on that loss, we have to update these weights. How can we update that? That is with respective. We have to find the derivative. What is the change? How much change is required here for this variable? How much change is there in that error? So that we have to identify, the differentiation has to be identified and it has to be applied on the weights with respective to that loss or error. We have to update the beta 1, beta 2, beta 3. First we will update. In the first cycle we will calculate this and update this, and then go to the next round again. After updation of the beta 1, beta 2, again next cycle, again you will get the y hat. Now you will get better result, and again you come back and continue this process. After some iterations you will reach a better model and with some parameters. I hope you are getting. So this is the gradient descent concept. We are going close to the truth, and we are reducing the error or loss. We are trying to reducing the loss by updating the weights. This is the gradient descent. Now after that we are applying the same concept can be applied on the logistic regression also, but there we have to apply the log functions because we are applying the log there. So we have to apply, according to that we have to apply the gradient descent on that only. The loss will be also again in the similar way. So this is about the parameters. Now what you can understand here is, it may be the linear regression or logistic regression, either of that. You are completely depending upon the weights, or beta 1, beta 2, beta 3, or W1, W2, W3. You are completely depending upon the parameters. So because of depending upon the parameters, these are called the parametric algorithms. Wherever you are using the W1, W2, W3, beta 1, beta 2, beta 3, these are called the parametric algorithms. And some other algorithms are also available. Without using these parameters, we don't have the parameters, we don't have the weights, we don't have the parameters. Those algorithms are called non-parametric algorithms. So the machine learning algorithms can be categorized into two ways. One is the parametric, non-parametric. Wherever you are using the W1, W2, W3 gradient descent concept, that is called the parametric algorithms. Non-parametric, you don't have anything, and in the non-parametric algorithms, KNN, K nearest neighbors, and decision tree. Decision tree also we don't have the parameters. Non-parametric algorithms. Okay, directly you can take one attribute based on the conditions. Just now you have calculated the entropy. For the decision tree concept, we have to select. Tree means there is the root node and there are the sub nodes. We can call them as the children nodes, and then there will be the number of levels, and root node and leaf nodes. I think you know about the tree structure. In that, first of all we have to select the root node. We have the number of parameters. We have 10 parameters. In our same example, we have 10 parameters. In these 10 parameters, we have to take one attribute as the root node. One attribute as the root node. Which attribute has to be taken as the root node in the available parameters? For that, we have to go for the entropy and information gain concepts. That's what you have calculated, right? So in the machine learning algorithms, we have the parametric, non-parametric. In the parametric, linear, logistic regressions are there. In the linear and logistic regression, we have different ways to estimate the parameters, and in the non-parametric, we don't have any parameters. There are some other methods to classify. I think you get the overall structure, right? Now what we are doing is, now ma'am will continue with the entropy calculation and the information gain, and then we will show you how to write the program and comparison with the logistic regression, decision tree and other algorithms also, and we will see the accuracy. What is the accuracy? After that, we will discuss about some other concepts, and we will go with the, we are planning to go with the multiple choice questions also, because we have to, you have to answer the questions, right? So, ma'am will continue with the information gain and entropy.
Okay, coming back to the session, we have as sir told, we have many classification algorithms where we have parametric and non-parametric. Okay, so which type of algorithms will depend on parametric? Just now we saw. What are they? Linear and logistic. Fitting the line is depending on beta naught and beta 1. They are the coefficients. They are depending on the weights or the parameters or theta 1 and theta 2. Multi-dimension, we see that it is theta. Normally in a single line, normally we see beta naught. Coming to the ANN, CNN, deep learning, all the parameters are called as weights. Linear regression, beta naught, beta 1. Logistic regression, theta naught, theta 1. And ANN and deep learning, W naught, W1, W2. Okay, yes. I want to talk, I have y cap which is W1 x1, W2 x2, so on Wn xn. Can I write like this? Can I write like this? Yes, see here. Can I write like this? Whatever the equation I have with n attributes, or can I write like this? Summation I over n, which is Wi into xi. Y cap is nothing but the predicted output and the actual value is there in the table. We are calculating the error. Just now think, yes. Now think, if the data is a table, we are thinking that we are converting this into an equation Wixi. Let me think about an image. If I want to map, what is the image? Image is having n by m rows and 32 by 32, and I need to get 32 by 32. What I need to do? If I want match y cap with a y, what I can do? I need to update the weights. I select the random weights, first initialize the random weights. To match I and I initialize the random weights to W naught. If it is, the prediction is not proper, what we need to do? Update the weights. If it is not proper, what we need to do? Again update the weights. Until which point we update the weights? Until we get a point. How we know? How an algorithm know? That's why we use gradient descent. What is gradient descent? It is the change of error with respect to weights, or it is the change of RMSE with respect to weights. Okay, yes. There is a very much importance in updating the weights. And normally for a big scientist, if we want to give any program, normally person will give gradient descent program. Please remember that how you are updating the weights. Okay. Why we have written T here? Can we multiply row by row? No. Always we need to multiply row with a column. That's why we take some transformation. This W represents the transformation so that we can multiply the row with a column of your image. If you are doing this weights with a column, do with a row as an image. So, there is, what is the importance of your weights? Weights are the mask which can predict the input and output relation, or which can predict the outcome. Yes, if you keep on changing the weights, you can get the classification very well. Okay. Yes. Now, coming to this, we know the decision tree. Yes. How many know decision tree? What is a decision tree? Always we select a root node where we have information gain. Based on the information gain, we select the subroot which is having highest information gain again in the sub samples, and again we divide into this. How depth we detect? How depth we can classify? Can we go deeper tree? Can we go deeper? Can we go deeper into tree? No. Why? Because the time complexity or computational time increases. As you keep on going to the depth of the tree, the computational time increases. Normally, to reduce the computational time, we prefer shorter trees. We prefer shorter trees and also wider trees. So, always we prefer wider trees than shorter trees. Okay. Wider trees and shorter trees. We prefer shorter and wider. Okay. Yes. Next, coming to the ensemble method. Please, this is very, very important. And I have talked optimization in my talk. I talked about evaluation. I talked about the third important ensemble method. What is meant by ensemble method is combining 2-3 decision trees and taking the majority vote of the based on the methods. That is what we call it as ensemble. See here, what I have done, I am giving a test sample. For the test sample, I have generated a tree with ID3 iterative dichotomizer algorithm. Next, I have used one more decision tree with a random forest, and one more I went with Navies Bayes or some other classifier. I am ensembling all methods. I am finding out the classification output. Whichever gives the best output, I will select on the aggregation method. What I have done? I have done with the one tree, decision tree method. I have, we have different types of decision trees. One is called as ID3 algorithm. One is called as classification regression trees. We have one more tree called as C4.2 classification 4 version. We give for different trees and each will predict one output. Whoever gives the best output, sometimes we take the average of that, or else sometimes we take the best out of it. That is what we call it as majority vote system. Last, when I give the majority vote and take the output. That is what we call it as. Can we run all the decision trees in parallel? ID3 somewhere, tree runs somewhere, cart somewhere runs, and C4.2 runs, I'll tell here. So I am running a tree at ID3, I am running at cart, and I am running that C4.2, and it is giving some accuracy of 85, it gives an accuracy of 70, it gives an accuracy of 75. Which I do? I take either average of all this, or else I can choose best out of it. This is called as majority vote system. Okay, yes. Can I run all this parallelly? Normally, parallelly we do that. Yes, this bootstrapping method, what we call bootstrapping. Always all algorithms are running at bootstrapping. Okay, parallelly, so that I can reduce my, what I can reduce? Computational time I am reducing. This method is called as bagging. Have you heard bagging? Okay, bagging means you are taking one algorithm, running out of it, calculate the accuracy, you take one more algorithm, run the accuracy, you get an accuracy, average all the algorithms, take best prediction. This is called as bagging. Some we prefer boosting. Boosting means sequential. First I run ID3, then I run the cart, third I run C4.2. Sequentially I run and I will take the output. Which is best? Do I predict in faster or in less time we need to predict? Means we go for decision tree with a bagging ensemble method. Bagging ensemble. Is it sequential or is it parallel? Bagging is sequential or parallel? Bagging. Bagging runs parallelly. It runs. Parallelly it is doing its task. Whereas boosting means one after the other. Okay. Yes? Yeah, these trees we can do with our algorithm, we'll see that. Okay. Coming to the KNN. We have a KNN. Yes, please remember that. We have a less time, we need to complete all the algorithms, basic algorithms. We can cover all that by using a simple problem. See my data set here. How many rows are there? How many rows are there? How many rows are there? How many rows? How many know KNN bit? How many people know KNN? K nearest neighbors. Okay, you know it? How we calculate the nearest neighbor? How we classify the nearest neighbor or a new query? Okay, yes. The simple method is Euclidean distance. Set, okay. Okay. How many rows are there? How many rows are there? 8 rows are there. But here you see the question. He told to find out the nearest neighbor should be selected 7. Whoever gives the lowest distance, that we select as neighbors. Okay. So how many are there? 8 are there. Among that, how many positive classes are there? How many positive classes? See the last column, class. 4. Now, how many negatives are there? How many negatives are there? Totally I have, how many neighbors I have to select? 7. So, I'll select the 7 neighbors. Okay. Now what I do, I calculate what is the, now what he has given, see there, suppose you want to predict a new class data. I have a new class data, this is our new class. What is new class? X1 is equal to how much? 1. Y1 is equal to 1. See there, question. Here we have a data point is equal to x1 is equal to 1 and y1 is equal to 1. I need to classify the new query. New query. This is what the external query is. I am giving external query. Now I need to do that. What I do, I take the x value and y value and I assume this as y2 and x2 and calculate the distance. How you calculate? X2 minus x1 whole square plus y2 minus y1 whole square. And I have how many? 1, 2, 3, 4, 5, 6, 7, 8. Among this, how many neighbors I have to select? 7. How to select it? Whichever gives lowest value, that we need to select. And after selecting that, we need to check how many samples are positive, how many samples are negative. Whoever gives the highest sample value, that sample will select. Try to do that. Calculate x1 is equal to 1, y1 is equal to 1 and x2 value and y2 value you take this. You assume this as x2, this as y2. For all this you calculate Euclidean distance. Negative class. For the new instance x1 is equal to 1 and y1 is equal to 1, the class is negative. You find out the lowest Euclidean distances. After that, whoever gives the highest, you write down positive or negative all over this. 1 you got it as 4.3. Among this, 4 you got it as negative and 3 you got it as positive. We have selected this 4 as negative. If both are same, what we do? We change the k. K can be reduced to 3 or k we change it to 11. There is one more possibility. We can change the distance measure. Minkowski distance, Manhattan distance. We can go for different distances and we do that. Can you do this? You have a confusion matrix. Is it evaluation method or metric? Is it a metric or evaluation method? It is also a metric, but we do, once we predict, we go with confusion matrix to evaluate. So based on this, you can calculate accuracy, precision and recall. You remember these formulas, right? Accuracy is what is precision? True positive divided by true positive plus false positive. We call it as positive rate, true positive rate. What is recall? Recall is sensitivity. True positive divided by true positive divided by true positive plus true negative. This is called recall. This is precision. What is the formula for precision? True positive divided by true positive plus false positive. What is the formula for recall? True positive divided by true positive plus false negative. What is the formula for accuracy? True positive plus true negative divided by true positive plus true negative, false positive plus false negative. One important point, please remember while doing confusion matrix, for any exam, if it is purely machine learning code requirement, always these are changed. Predicted will change here, actual will change here, so that the places changes, the placement of true positive and true negative also changes. True negative comes here, for true positive goes here, false positive come here, true negative goes here. Have you heard about type 1 error and type 2 error? We call it hypothesis testing. Normally in hypothesis testing, we call type 1 error and type 2 error. Okay. Next, last evaluation matrix is your ROC curve. What is AUC? Area under the curve, and ROC is called as receiver operating curve. How best the system is working? How to evaluate that? When the ROC is very near to the recall. What is the one more evaluation matrix? Whenever the sensitivity or recall value is near to the receiver operating curve, always we say that the evaluation, no need of gradient descent. You can do this and you can say it is bestly classified, properly classified. There are different, one way is seeing your confusion matrix, second way is gradient descent, third way you can do it with ROC curve. Okay, normally whenever we talk about this confusion matrix for classification, whenever we go with ROC curve. Where ROC curve, always area under the curve, we know that this is the blue line is the area under the curve and this is the ROC curve. It is true positive rate to the true negative rate, false negative rate. Okay. So 1 minus specificity and we call it as with recall. We curve with this. We have done, what are the evaluations we have done? We have calculated misclassifications. Why we have calculated misclassifications? Number, and we have done the confusion matrix to plot this ROC curve. If you have an ROC curve better, you can say the model is very, very best. Okay, the model is very best. Okay. Yes. Can you see this? Can you see this? Can I design an AI system? This is the database where I have data set. What is this? I am giving the images as an input to the machine learning algorithm and training. If it is bestly classified, I go and display in the medical record. What is the interface between your model and your HTML page? There I am using one API, which is our Flask API. This is one AI system. What is this? It is a brain scan. Why, how you are transforming all this into colors? Always I am talking about matrix W transpose. When I transpose well, I can change the image into. Is it an AI system? Can I call this as an artificial intelligence? I'm taking the images, I'm giving to the training model such that it is printing detected or not detected on my laptop or a computer or on my HTML page. Can I do this? It is a simple AI project. This is the extra. You can replace the computer with mobile, you can replace anything with your mobile. Yes? Yes. This is what I am talking about. When it is a successful model, what are the things I need to do? First, in my starting of my class, I have done 8 steps. Select random state. Second, split it well. Then, what we have done? Choose a correct model or an algorithm based on the data set. Fourth one, fit the model, predict the model. Then, if more misclassifications are there, what we do? Update the parameters which are weights. Once weights are updated, what we need to do? We need to evaluate them. This is the model of my AI. And not only this, anything you can give as an input. Okay. That's it for today. Sir will continue with the session. Okay.
Till now we have done with the training. Now we have to go for the testing. Right? I'm not giving any question paper or I'm not going to test you. You have to test yourself. Because there are no marks, there are no special gifts or anything. Right? Only the thing is, you have to evaluate yourself, how you have done. And these 3 days we try to cover some important algorithms, and actually as per our plan, we have to touch the deep learning concepts also, but I think it is heavy loaded for you because see, I'm seeing that for these algorithms also I think it is a little heavy, because in the short period of time it is very difficult to cover all these concepts. All these concepts actually we will take 6 months or at least 2 or 3 months minimum 2 to 3 months we have to take these sessions. Okay, but we have made them in 4 sessions. Okay, but we try to give you what is the importance and the key terms. I think you are able to recognize the key terms. Actually, what we expected is most of you have already attended the Sonnet classes and all, so that we can cover more concepts, but unfortunately most of the participants have not attended any machine learning concepts. So that was the challenging for us. So, and now what you have to do, whatever it is, whatever the past is past. Now we have to attempt the exam, there is no chance, right? In this, the first step is MCQs. You have to attend the MCQs. So how can we handle the MCQs? And we have done so many calculations and theoretical parts and programming part we covered. Okay, in MCQs, what we will expect, we don't know. And what we can do is we have to practice a little bit. Where should we practice these MCQs? And where can we get that? See, here we are making it open, and in the internet directly you are having so many MCQs, right? In that also, what I am planning is, I just want to open one of the MCQs and let us solve 3 to 4 questions, okay? Simple questions, and then go for the next, and we will try to start at least. And then you have to practice today in the night, you have to practice minimum 100 questions if you are able to solve, not only from the machine learning, it is from the probability, linear algebra, and all the mathematics concepts. Okay, so because first step is you have to cross the MCQ test, then only you can go for the interview. Interview is different again, but for MCQ, to cross that first step, you have to handle the MCQ. So I'm just showing some MCQs here. First you start with the low level and basic questions. You try to understand the basic questions. We are not giving from the college website or anywhere. We are directly open source and on the websites. Okay, and go to the websites and you can search for the MCQs for machine learning. You just see this here. Yeah. This is a first level, basic level. If you are able to cross this, then go for the next level. Okay, first start with this level. So what is that first one? Please read and answer the question. Semi-unsupervised, I am getting this answer. How many of you agree with this? Okay. Semi-unsupervised, there is no semi-unsupervised. Semi-supervised is available, but not semi-unsupervised. Supervised, unsupervised, semi-supervised, reinforcement. These are the 4 types, but there is no semi-unsupervised. So go to the next one. Patterns. Recognition patterns, right? How many of you agree with that? Okay. Next one. Yes, third question. How many of you agree with both A and B? How many are with batch learning? What is offline and batch learning? What is offline? What is the batch learning? See, the data, there is an online learning, online or batch. Okay, meaning that if the data is continuous, like Facebook or WhatsApp or the stock market, all these are the continuous data, continuous flow of data. That is the online learning. If you are training your model on that, then it is called the online learning. And if you have some fixed amount of data, I have these many pictures, and based on that, I want to classify this. Fixed amount of data available, and that will not change frequently. Okay, occasionally if it is changing after 5 days or 10 days or 1 month or 1 year, if it is changing, then we can go for the batch learning or offline learning. It is not the online. Online means continuous. Okay. Next one. How many of you agree with big data? How many of you agree with big data? Any other answer? Data mining. How many of you agree with data mining? Okay, I'm going with the data mining. Large amount of data means don't go for directly big data. See, the machine learning methods to a large database and machine learning. Big data is not having directly machine learning. Big data is data handling techniques. How to processing. On top of the big data, we can apply some machine learning algorithms. That is different case. Okay. Next. How many of you agree with reinforcement? How many of you agree with unsupervised? How many of you agree with supervised? Okay. PCA. True or false? And what is this? Dimensionality reduction. Dimensionality reduction. What is the dimensionality reduction? Yesterday I think I have given some outline for this. Feature engineering concepts I have given, I think. Dimensionality reduction means the number of dimensions will be there, number of operations that we have to reduce. We have to reduce the dimensions to avoid the overfitting. Overfitting. What is the overfitting? What is the concept of overfitting? This point actually I didn't touch. Trained data. If we get the very good accuracy for trained data and less accuracy in test data, then it is called overfitting. Right? And underfitting. What is underfitting? For the training data itself, if you are getting the low accuracy, it is called underfitting. It was not fit. Overfitting means if you get the good accuracy for the training data and less accuracy on the test data. How can we handle this overfitting? Huh? What is that? Simple words, in simple words. Early stopping, okay. Argumentation, okay. Argumentation, will it help you? Epochs, early stopping, it is okay. Add some noise. Add some noise. Add some noise means regularizers. Regularize. Regularizers. L1, L2. L1, L2 regularizers. I think Yunus sir is going to cover this L1, L2. I think tomorrow's session you will have that. Okay, regularizers. We will use that regularizer concept here. In the overfitting, to handle the overfit, we have to go with the L1, L2 regularizers. Okay, next. Okay, what is this? Okay, so like this is the the basic level MCQ. Okay, please go through first. And the next one. See, I am not going to discuss all the concepts here, all the exercises here. I am just going to explain you what is the level you have to go. First you should go the previous level, and then if you are comfortable with that, then go to this level. If you directly come to this, you cannot understand anything. First you should have minimum knowledge, step by step, right? And then you can go for the higher levels. And in your examination, not only these machine learning MCQs, you should go with the probability, linear algebra, and then statistics, Python also, Python basics also. It is also mentioned clearly, and data science toolkit. Data science toolkit is having NumPy, Pandas, Matplotlib. Okay, EDA. You can go with the EDA concepts, up to EDA concepts. And machine learning basics they are asking. I think it is not that much complicated. Okay, if time permits, again we will meet. Tomorrow I think you will have the some additional session for the mathematics. Okay, because most of the questions are from mathematics, right? So I think we have done with this, and your path is you have to attempt number of MCQs like this. Okay, there are the explanations also there. Please write down those MCQs. If you have any questions, yes, all of you listen please. If you have any questions in the explanation also, if you have any doubts, please come to us. Tomorrow anyway we will be here. Okay, I will come here at some time, in the break time I will be here, and we can discuss about the explanations if you have any questions. Okay, all the best, and please practice the number of questions. Okay, if you go to the number of questions, you will automatically understand how to handle that. Please do the practice. Okay, thank you for listening.